That water is called the core water. There is one more type of irrigation initially to moisten the dry soil. That water applied to the field, that water is called the paleo irrigation. And first maximum watering to the field, that is called the core water. And base period and crop period. Base period is the first watering to the last watering before harvesting. That is the base period. And crop period, the day you are sowing to the day you are harvesting, that long time frame is called the crop period. So different types of water requirements are shown in this picture, and the problems with it. And duty, I was discussing about the duty. Duty is the number of hectares of land that could be irrigated if the discharge rate in the canal or irrigation system is having only 1 cubic. And there is a relationship between this duty and delta, depth of water and number of hectares of land with 1 cubic discharge rate. And this relation is delta equals 8.64 b divided by d meters, or 864 b divided by d centimeters. And related to this, and duty is varying. The position of the canal system very close to the irrigation field will give you the maximum duty, and the farthest position will give you the less duty, because there are different types of losses in between the passages in canal system. So at source the duty will be less. Close to the irrigation land, that will give you the maximum duty. And importance of duty was discussed, and we could also improve the duty of water, and by taking two types of precautions in field preparation and sowing, and also precautions in handling irrigation supplies, we can minimize the duty. Now, each crop has its own sowing and harvesting seasons, and it is important to have the knowledge of this, which may help to decide the total water demand in the field, having mixed crop. You might know this, there are two main seasons, Rabi season and Kharif season. Rabi season, this is the starting of actually the Rabi season. Not right now, it started few days back, Rabi season. Rabi crops are, say, potatoes or cabbage, cauliflower. What are these type of vegetables? Brinjals, radish. All these types of vegetables are basically called the Rabi crops, and which need actually maximum irrigation water. Without irrigation, it is not possible. But the Kharif season, these are mainly in monsoon times, and mostly the water is coming, that is from the rains. As you know, in our country, after April to before October, or up to October, we can see the rains in our country. And after October to March, to the month of March, or even up to the mid of April, there is no rains, superficially rains in our country. And depending on this, so you can divide total seasons for the crops into ways. One is Kharif season and Rabi season. Rabi season is basically starting from month of October to March. Okay. Kharif is characterized by a full gradual fall in temperature, more numerous clouds, low intensity, high relative humidity, cyclonic weather. And Rabi is the lowest temperature and gradually rising after January or after February. Bright sunshine you can see, mostly almost absence of clouds. So these are the time frame for the Rabi season and Kharif season. there are some mistakes, as you can see. The Kharif crops are also called summer crops. This is not Kharif crops, this is Rabi crop. Okay. Rabi crops are called also winter crops. This is okay, but this line should be there, and these Kharif crops would be there. And Kharif Rabi ratio or crop ratio, ratios of areas to be irrigated in Kharif season to Rabi season is generally 1:2. So, as Kharif season is inside of the rainy season, for that reason, we do not need to have proper arrangement for the irrigation systems. But Rabi season is completely dry season. For that reason, we need to have proper arrangement for the irrigation systems. And the amount of land to be irrigated in Kharif to Rabi is 1:2. If only 1 acre is irrigated in Kharif season, 2 acres land will be irrigated in to grow crops. We need to irrigate almost two double areas of agricultural land to be irrigated. Cash crop encased in the market for processing, as it cannot be consumed directly. This type of crops cannot be consumed directly. So jute. You can grow this type of crops, but you cannot consume those directly. But producing some other goods, you can earn huge amount of money. For that reason, those type of crops are called cash crops, jute, tea, cotton, tobacco, etc. What is crop rotation? You know, if you do not want to use any fertilizer or manures, in that case, you can sow different types of crops at different times. It will refill the nutrient contents in the land, and by this way, throughout you can try to get good crops. And because of doing this one is basically called the crop rotation. Optimum utilization of irrigation water. In an identical situation, yield is going to vary with the application of different quantities of water. The yield increases with water. The yield or crop gives you maximum yield, maximum output with the increase in water, but reaches the maximum value, and then if you apply more water, crop will not give you more yield, rather yield will fall down. The quantity of water at which the yield is maximum, that amount of water is basically called as the optimum water depth. I gave you already one example that you did this type of experiment in level 3 new soil course, that is maximum dry density versus optimum moisture content. This is more or less same. Optimum water depth giving you the maximum yield. Less than this depth of water will reduce the yield of your crop. Now come to the use of water. About the use of water. Basically, for the consumptive use, this is called the CU. And this consumptive use is basically consumption of the water in the irrigation field or crop field by two. One is evaporation, another one is transpiration. What is transpiration? Can anyone tell me? Transpiration, as it is written here, water entering into the plant roots and used to build plant tissues and being passed through lips, stomata, being passed through lips of the plant into this atmosphere. This water is called this process of water transportation is called the transpiration. Entering the water into the plant roots, then gradually moving upward direction, building the tissues of the plant, and finally through the leaves, opening of the leaves. That opening are basically called the stomata and living into the atmosphere. So entering into the roots and finally building the tissues, living into the atmosphere. This consumption of water is basically called the transpiration, and evaporation, not entering into the plant tissues, rather from the surface of the land, the water is evaporating from the adjacent soil or water surface or surface of leaves of the plants, or intercepted precipitation, intercepting water. From all those areas, the waters are getting evaporated. So by these two way, conjunctive use is uh, is made, and these two, one is transpiration, another one is evaporation, both simultaneously called as evapotranspiration. And this evapotranspiration is called the conjunctive use or CU of any plant. Factors affecting the CU or conjunctive use or evapotranspiration, those consist of evaporation affected by, maximum sun or temperature of air and soil will evaporate maximum water. So evaporation definitely affected by temperature, degree of saturation of soil surface. The more this saturated, the more will be the possibilities of evaporating. Less humidity, like in these days, in November, December, January, the humidity of the environment is less in our country, so maximum evaporation takes place in this dry season. Wind velocity, the more the velocities of wind, it can blow away the evaporated water. So wind velocity will increase the evaporation rate, extent of vegetative cover. More it will be more. Transpiration affected by evapotranspiration consists of two, affected by because of two, evaporation affected by and transpiration affected by. Evaporation affected by, you already got the degree of saturation of soil, temperature of air and soil, humidity, wind velocity, extent of vegetative cover, and transpiration. There are many factors: climate factors, soil factor, and also plant factor, because these three are interconnected each for transpiration. Climate factor, temperature. The more will be the temperature or in climatic situation, temperature will be more, means transpiration will be more. Humidity in the air, less the amount of humidity, more will be the transpiration. Wind speed, same as the evaporation rate, duration, intensity of light. The more the length of the duration of light, daylight, the more time the stomata will remain open. So the more will be the transpiration rate. Atmospheric vapor pressure, depending on the changing of vapor pressure, less vapor pressure means more transpiration. Soil factor, it depends on texture, structure of the soil, moisture content, and also hydraulic conductivity. Hydraulic conductivity basically depends on the porosity of the soil, but electrical conductivity basically depends on the soil or mineral contents in the soil. Plants factor, efficiency of root system. A good or efficient root system can absorb more water and transpiration consequently will be more. This is not the leaf arc, this is the leaf area. The more will be the leaves in a tree, the more will be transpiration. Leaf arrangement and also structure of this leaf and stomatal behavior. Depending on all these factors, uh, evapotranspiration or consumptive use will increase or decrease. I think I forgot to start the recording of this meeting. Let me start once again. So, is there any question? Do you have any question to discuss? Let me check how many students of you are having with this. Oh, right now this is 71, 70 students. Abu Tawhid Shohan. Abu Tawhid Shohan. Yes, sleeping. He is sleeping most probably. Abu Tawhid. Mr. Abu Tawhid. Abu Tawhid.
Yes, sir.
Are you sleeping?
No, sir.
No, sir. Very strong voice. No, sir. Can you listen to him? All other students, can you listen to him?
Yes, sir.
So can you feel that how strong his voice is? But he was not with the laptop
No, I
or
have some net problem, sir.
are you discussing with your brothers or sisters?
No,
Be
no, sir.
close. Be close to the device. Be close to the device. Okay. Do not keeping the device open. Do not go any other where to discuss with your brother or sister or any other. Okay.
Yes, sir.
Anika Farjana,
Yes, sir.
are you there?
Yes, sir. I'm here.
Okay, fine. So, Abu Tohir, do you have any question? Can you explain me what I already said or one or two topic that you listened? Abu Tohir,
Yes, sir.
yeah, explain me about the conjunctive use.
Sorry, sir.
Sorry, sir. Yes, you are not there. All students, dear all students, can you understand right now what was happening with Mr. Abu Tawhid?
Sir, I have some net
Do not.
problem, sir. I can hear you properly, sir.
Right now you are coming to the point. Net problem. This is a common allegation
No, sir. Seriously,
from
sir. Our
students.
broadband connection
No,
is
no,
too
no,
bad.
no, no. Okay, okay. Seriously, I am taking it also seriously. There is a very common allegation from students that whenever a teacher is asking, where is this boy or where is this girl? After coming 2, 3 minutes later, he or she was saying that there was a problem. Sharia, close the microphone. Sharia,
Yes, sir.
close the microphone.
So actually, I have a question. Can I
Yes,
ask?
yes.
Sir, can you explain again about the extent of vegetative cover?
Extent of vegetative cover. Yeah, the more
Yes,
will be
sir.
the vegetative cover, the more will be the extraction of water from the soil surface, and in the vegetative cover, there will be the more what stomatal behavior, and also it can reduce conjunctive use as well because by evaporation the vegetative cover is preventing direct evaporation from the soil surface. Okay, so one thing is doing by stomatal way, transpiration is increasing, but it can reduce the evaporation. Okay, vegetative cover decrease the evaporation rate, but vegetative cover increase the good transpiration rate. Are you getting me? There are two terms. One is transpiration, that is entering the water into the plant roots and finally leaving into the atmosphere by stomatal opening. Okay?
Yes, sir.
And evaporation is the direct water entering into the atmosphere from the soil surface or water surface or any other or precipitation or any other surface. So increasing transpiration and reduces direct evaporation. Anything more?
No, sir.
Yeah. So let me explain how to measure this evapotranspiration or consumptive use. Lysimeter experiments or tank experiment can also be said. Okay, and there are three types of lysimeters: non-weighing constant water table, non-weighing percolation, not the constant water table. Let the water to percolate into the soil, and also we can make the weight measurement of this water that is entering into the field, into the experiment environment. So lysimeters are the instruments that can measure how much water is entering into the experiment environment and how much water is getting consumed by plants or by the environmental process, that is the evaporation, and plant process means the transpiration. Okay. Limitations: reproduction of physical conditions such as temperature, water table, soil texture, density. This is not actually possible. So artificially you need to make all those systems and may not more or less identical. So these are giving yes. So there are three types of lysimeters: non-weighing constant water table. Water table will remain all the time constant. And once again, you are applying water to the lysimeter. Let the water to percolate, not keeping the water table constant. And also you can measure the weight of the water that is entering into the environment. So three types. Non-weighing constant water table. This is the more or less the picture of lysimeter. Water is somehow applying at one part, and from another direction the water is moving out or leaving out the experiment area by surface runoff, and most of all the time water surfaces are remaining same. At the same time there could have percolation, there could have evaporation. All this constant water level is maintained by applying water, the amount is entering minus the amount is leaving. The, the remaining amount of water, balance this. The remaining water, applying water minus leaving water. There will be, these two will not be equal. The balances will be the consumption because of the evapotranspiration. And effective rainfall and irrigation are measured by rain gauge. You are applying this water, you can easily measure these two water. Very good. But whenever there will be a rainfall, this you need to measure by rain gauge. And if you apply any irrigation water to the field, you need to measure this by calibrated container. Overflow, deep percolation, if any are measured using this equation. Maybe 0, effective rainfall, overflow maybe 0, and deep percolation maybe 0. This method is applicable where high water table in soil exists. This is non-weighing tape but percolation. At the bottom you just see there is inclined surface. There is an inclined surface and both these sides there are two air vents. One is air vent, another one is pumping tube. So from the top of the soil, from this soil, water is applied there. Water is applied there and gradually water is going down towards the bottom and ultimately coming to this area. Okay, this is storing zone, and this is a bronze grid, so that soil cannot come to this zone. Only water can percolate to this to come down to this zone. How much water is coming down from this soil system? It's coming to this, and this pumping tube is used to collect this water, and you can measure the amount. Okay. By adding measured quantities of irrigation water, consumptive use in this way can be computed by adding measured quantities of irrigation water and the effective rainfall received during the season from the rain gauge and the contribution of moisture from the soil. And this is that equation that can be measured. There is MBI and MEI, moisture content at the beginning of the season in a particular layer. This soil zone can be divided into number of soil layers. This soil zone can be divided into number of soil layers. In a particular soil layer, how much water is available, that can be measured by what moisture content experiment, by the way of calculation of moisture content here. And this is done very beginning of the season, and after the season once again the moisture content is calculated. So there could be many layers, 1 to n numbers of layers, the difference, and multiplied by apparent specific gravity of ith layer and depth of the ith layer zone. This will give you the moisture difference in moisture content and irrigation water, effective rainfall, and depercolation. This is addition, this is used, and this is the remaining. So this will be the amount of calculated evapotranspiration. Weighing tape, more or less same arrangements are made. More or less same arrangements are made, and there are the pillows. These are the soaking pillows. You can collect those after the soaking. Then how much water is getting soaked, the weight of water can be calculated. This is the process of way of measuring the evapotranspiration. More or less same arrangement as you can see in the previous one. This. At the bottom, the soap pillows can be measured. Weight can be measured. Soil moisture depletion studies. There you can see application of water or rainfall. There could have some surface runoff. There could have some deep percolation, and there will remain some moisture in the root zone, and at the same time evapotranspiration will be happening. And knowing all this, irrigation water, how much water you are applying, you can easily measure. Runoff, you can measure the amount of water that is getting runoff from the surface of the land, you can easily measure. Rainfall, if there is anything from the rain gas, you can easily measure. Deep percolation, knowing the permeability of a particular type of soil for a particular field, irrigation field, how much water could be percolated or could be into the deep percolation zone, you can easily calculate. And remaining moisture content can be calculated by previous way. Initial first sampling time in a particular layer, and moisture content in the second sampling. This could be at the starting of the season, this could be at the ending of the season. In between, how much water is depleted, that would be the available moisture in that particular zone. And by this way, how much water, how much you applied, how much you got from the nature, how much going out from the land, how much deep percolated from the soil system or permeability experiment you can get, and how much it is available. So what is the total amount of consumption of water in a particular crop field? That is the evapotranspiration calculation. By applying some empirical formulas, you can also calculate the evapotranspiration. These are the experiment methods. And without experiment, some empirical formulas are also there to calculate evapotranspiration. And one of these formula is a very common, Blaney-Kriegel formula. It is used extensively. It gives good estimate for seasonal water needs under arid conditions, as was developed initially. But some limitations are also there, not suitable for a period shorter than 1 month. So monthly consumptive use in centimeter CU, there could have one crop factor, and this crop factor definitely will be different for the different types of crops and can be determined by experiment. Mean monthly temperature in degrees Celsius, T. Monthly percent of annual daylight hours that occurs during the period in our country, it can be known very easily because we know about the environmental situation of our country. Our department of environment can give you this type of data easily. Okay, so if the term in the bracket except the K, from P to the term in the bracket, if you take out and represent as F, so CU conjunctive use can be once again written in short as KF. Depending on these equations, you can see some problems in your book, Irrigation and Hydraulic Structure book by Santosh Kumar Garg. You can determine the evapotranspiration and consumptive irrigation requirement of this particular type of crop. This is a wheat crop, and suggesting you to use Blaine-Friedel equation for the calculation of your evapotranspiration or consumptive use of that particular type of crop. Here, in this example, this problem, the crop type is wheat. Crop factor you need to know. As you know, this can be calculated by the use of experiment, as no separate experiments is there. So this crop factor is also given to you, that is 0.8. And there are the data of monthly temperature averaged for almost 5 years, and the 4 months data are given to you: November, December, January, and February. Monthly percentage of daytime is also given to you in hours: 7.2, 7.15, 7.3, and 7.1. And useful rainfall in centimeter is also given to you. And use now the Blaine-Friedel to calculate the evapotranspiration. And previous data is taken into this chart. Once again, P, R, E, T, and by using this data, calculate the F for individual months and do the summation for the effective rainfall and for the F. So CU is K into summation of F. K is given already 0.8 and summation of F is 42.7. So consumptive use is 34.16. So in every month, total for this total time frame, the consumptive use for this particular crop is 34 centimeter of water almost. Consumptive irrigation requirement, effective rainfall is there, so you need to supply 25.78 centimeter of water to the irrigation field for pleasant nourishment. If there is any efficiencies given to you, then you can calculate the field irrigation requirement, FIR. That is actually something will be lost. 20% water will be lost. For that reason, you need to actually design the canal to carry 32.225 centimeter of water for the Rabi season. Okay. There are so many problems you can see in your book listed here also. I'm not explaining all those, you can see in your book. So we started to see about the empirical equations to calculate the evapotranspiration. One is discussed, that one is Blaine-Friedel formula, empirical formula. Another one is Grips class APN evaporation method. You can see also these equations in your book. And depending on this empirical formula, you can see some done problems or examples in your books as well. And also for Penman-Monteith equation, using these three empirical formulas, you can calculate evapotranspiration. Also, you can calculate the evapotranspiration by experimental methods by using the lysimeters, as I already discussed. Velocimeters are also three types: constant water table, percolation type, and also weighing type. Constant water table and percolation types are non-weighing type. So either the arrangement or facilities you can calculate the evapotranspiration by either by experimental method, or if you have the sufficient data, then you can use the empirical formulas to calculate the evapotranspiration. So by knowing the evapotranspiration, you can predict how much water to be supplied to the irrigation field, and these data can also be utilized in later segments of this course, so that you can get some ideas for the designing of canal systems. Okay? Effective rainfall, precipitation falling during the growing period of a crop that is available to meet the evapotranspiration needs of the crop. That's called effective rainfall. If any rainfall is helping you, you need to apply almost 40 centimeter of water, but you are getting some water, say 8 centimeter or 10 centimeter from the environment as the rainfall. That is directly usable for the nourishment of the crops. That 10 centimeter of rainfall is called as the effective rainfall. It is that part of rainfall which is available to meet evapotranspiration needs of the crop. So effective rainfall, the amount of rainwater that is coming from the nature, but out of this rainfall, some will leave your place as the surface runoff, and some will definitely go into the deep part of the water table to meet into the mix up with the water table, that is called the deep percolation. So the amount of precipitation you are having minus the amount of water that is leaving your space as the surface runoff, and at the same time the amount of water getting into percolated. So subtracting these two parts, you will get the effective rainfall. So which one is getting lost? It's not your effective one. The amount that is remaining, that is your effective one. So effective rainfall is the rainfall minus surface runoff minus deep percolation. So some factors are definitely affecting this effective rainfall characteristics. One day you are getting huge amount of rainfall, it will not give you that much of advantage. Rather, slowly, intermittently, if it is coming down to the earth, to your irrigation field, it will give you more benefits. Land slope is also a affecting factor for the effective rainfall. Steep land slope will not help you. Soil characteristics, groundwater table. If groundwater table is at very deep part, then more water will be lost because of the deep percolation. So you will get only a small amount or small quantity of rainfall that you can say as the effective rainfall. Crop characteristics, land management practices, carryover of soil moisture, surface and subsurface, in and outflows. If there is the available or this type of junctions of lake, any streams or any canals or any this type of water sources, and then the percolation. These are the factors that can affect for the effective rainfall. So we started calculation evapotranspiration, and there this is a very important term, that is effective rainfall. From that one, you can easily get the prediction about how much water you need to supply to the irrigation field for the fruit plus nourishment of the crops. And after that net irrigation requirement, you can calculate from this equation. That is, net irrigation requirement equals evapotranspiration or consumptive use by a particular type of crop minus effective rainfall. You are getting this amount as the supplement from the nature. Groundwater contribution, if there is any contribution from the groundwater, then you can truncate from the total supplied water. This amount of water you can truncate, or you can reduce, you can preserve, or you can conserve this amount of water not to supply to them, because you are getting from the nature and also from the contribution from some other site. And if any available moisture is there, stored soil moisture is there, it will also help you for the evapotranspiration. So after knowing perfectly the evapotranspiration and effective rainfall, you can easily calculate how much water you need to actually supply to the irrigation. That is, you can write irrigation requirements. And then from the net, you can go for the calculation of the net irrigation requirements. That is also per requirements consumptive use and any effective rainfall. From the net irrigation, then you can go for the field irrigation. If there is any loss because of the application in the field, application of in the field. So net irrigation divided by efficiency of water application, then you can get the field irrigation requirement. And gross irrigation requirement, then you need to take the calculations, considerations about the loss in the process of conveyance of water from one place to the irrigation field area. So field irrigation divided by conveyance efficiency, you can get the gross irrigation requirement. So by knowing evapotranspiration, effective rainfall, you can calculate net irrigation requirement. Then from there, leaving some part or adding some part of water that will be lost because of the application efficiency. Then you will get the field irrigation requirement. After that, the amount of water that will be lost because of the conveyance, adding that part, you can calculate the gross irrigation requirement. So starting of the source of irrigation water, when you are going to supply, you need to calculate for this GIR. You are allowing to supply this amount of water. Some will be lost in the way, and after moving it into the irrigation field, then there will be also some loss because of the application process. Then the amount will remain. That will be the net irrigation requirement. So depending on this, some problems will be there. I want to conclude the class today, and the remaining segments of this chapter will be discussed in the later days. Thank you very much. I'm stopping the recording of this class. Thank you very much. Hopefully to meet you on Wednesday, next Wednesday.